Okay, so let's start the chapter chemical bond. So today what we are going to discuss about electronegativity and the factors which influence the electronegativity of the elements. Trends in electronegativity across a period we'll discuss, and down the loop if it increases or decreases. I hope you have heard about this term electronegativity in your previous IGCSE levels. Then we'll see the differences in Pauling electronegativity value. Pauling is the name of scientist. Okay, he gives us the electronegativity scale, which predicts the formation of ionic compounds and the covalent compounds. So these all things we are going to discuss today. So first of all, as the chapter name is chemical bonding. What is chemical bonding? So it is actually a force of attraction between two atoms or two or more atoms or molecules or ions. Okay, so it is a bond. Bond means force of attraction which is formed between two atoms, two molecules or two ions. Now, why there is a need to form a chemical bond? Why atoms combine with each other to form bonds? Because to achieve noble gas configuration, that means to achieve maximum stability. And you know that stability is inversely proportional to energy. The more stable the compound is, the least is its energy. Okay. So there are three reasons of why a chemical bond should be formed. So to achieve noble gas configuration, to achieve maximum stability, and to achieve minimum energy. Is it clear the definition of chemical bonding and why we are going to study this chapter, why we are forming chemical bond?
Yes.
Please note it down. So chemical bonds, they are formed by the joining of two or more atoms. For example, in water, a chemical bond is formed by the joining of two atoms, H and O. Right? Similarly, another bond is formed between the joining of these atoms, O and H. So this is a chemical bond formation. So this is a chemical compound which is formed by joining of two or more atoms. A stable compound occurs when the total energy of the combination has lower energy than the separated atom. So as I already told you that a stable compound, if a compound is stable, that means its energy is lesser, its energy is lower. So stable compound occurs when the total energy of the combination has lower energy. Energy should be lower in a stable compound than your separated atom. Clear?
Yes.
You want to write it?
Just the second point. Done.
Okay. So we'll read about electronegativity first. So electronegativity, it is just the ability of an atom to attract the shared pair of electron towards itself in a covalent bond is called electronegativity. For example, if we have a bond of HF, hydrogen fluoride, so electronegativity of fluorine, it is greater than electronegativity of hydrogen. What is electronegativity defined as? It is basically in this bond we have what? We have electrons. Okay, we have electrons, two electrons. So electronegativity, it is the ability of an atom of fluorine because it is more electronegative to attract both these electrons towards itself. Okay, so it becomes partial negative charge because it attracts electron towards itself and it becomes partial positive charge. Okay, why partial? Because not all the electrons are attracted, not the all the electrons are attracted to fluorine. They just come closer to fluorine. So that's why the charge is partial here. So this phenomenon arises from the positive nucleus ability to attract the negatively charged electrons in the outer shells toward itself. As you know that the nucleus is positively charged, so it attracts the negatively charged electrons towards itself. Now we'll use a scale to measure electronegativity values, and that scale is Pauling scale. It is used to assign a value of electronegativity for each atom. Okay, so from Pauling scale only, we get to know that fluorine is the most electronegative element in the periodic table. Clear?
Yes.
Note it down.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-Level. Start learning with us today.
Done.
I'm done.
So these are your Pauling electronegativity values. So you need not remember the values, but you should have an idea that which element is electronegative and which element is more electronegative, right? So hydrogen, its value is important, it's 2.1. Carbon, you should know it's 2.5. Fluorine, you should know 4.4. So fluorine is the most electronegative element in the periodic table. Okay, so you can see here Na, sodium, its electronegativity value is very less, 0.9. So it is not electronegative element. It is known as electropositive element. Similarly, chlorine, its value is 3.0. Oxygen, its value is 3.5. So which is the most electronegative element in the periodic table? Chlorine. After that, we have oxygen. And after that, we have nitrogen. So we can say that nitrogen and chlorine, they have approximate equal electronegativity value. So these are your four most electronegative elements in the periodic table. Okay, so please note it down.
Very
So next is what is effective nuclear charge. Because these are the factors which affect electronegativity. So first of all, we learn what is effective nuclear charge. It is also represented by Z effective. Z means your nuclear charge, and in the subscript we will write E double F effective. So it is a net overall positive charge which an electron experiences from the nucleus. You know that this is your positively charged nucleus, and in the outer shell you have electrons. So suppose if this is the electron of interest, okay, and these are your electrons between electron of interest and the nucleus. So they cancel some of the positive nuclear charge here. Now electrons outside of this electron of interest, they have no effect on the effective nuclear charge for electron of interest. So basically, what happens in effective nuclear charge, you have a nucleus here. In the shells, you have electron. So if you want to calculate the effective nuclear charge on this electron, so there are other electrons also inside this this electron of interest. So these electrons, they just steal the valence electron, that means this electron from the nucleus. So these electrons, these inertial electrons, they lower the effective nuclear charge on the nucleus. And the shielding effect of electron, it reduces the attraction between the nucleus and the electron. What they do, they act as a shield. They shield the charge of the nucleus to reach to this outermost electron. So they act as shielding effect. Okay. So what is effective nuclear charge? That means overall positive charge of the nucleus which is reaching this electron of interest is called your effective nuclear charge. And what is nuclear charge? Nuclear charge means the total charge on the nucleus. Okay, the combining protons and neutrons. Whatever the total charge on the nucleus is, it is called the nuclear charge. Effective means the charge of the nucleus which is reaching to this electron of interest. Okay, after considering the shielding effect of inner electrons is called the effective nuclear charge. Is it clear?
Yes. Done.
Okay. So this is a better visual representation of your effective nuclear charge. How to calculate it? It is the actual nuclear charge minus your shielding effect. Actual nuclear charge is the charge on the nucleus, which is equal to Z, or the number of protons, minus your shielding effect due to your number of inner or core electrons. So this is the nucleus. Okay, these are my inner shell electrons and these are my outer electrons. So what happens? Nucleus is positively charged, right? And electrons are negatively charged. So there is an attraction of electrons to this nucleus because positive and negative attract each other. But here electrons in inner electrons are also negatively charged, right? And outer electrons are also negatively charged. So there occurs a repulsion in these electrons. So they tend to repel this outer electron. So that's why your effective nuclear charge decreases to these outer electrons. Okay, due to this shielding effect, due to the effect on the inner electrons. So please draw it in your notebook. This is a better visual representation of nuclear charge. Let me clear this. Where positive and negative they attract each other, and negative inner electrons with the negative outer electrons, they repel each other.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Yeah. Done.
Almost done.
Okay. What are the factors which are affecting electronegativity? The first factor is a nuclear charge. So that's why we are learning what is nuclear charge and what is effective nuclear charge, because this is one of the major factors which affect your electronegativity. What is nuclear charge? It refers to the positive charge of the nucleus, which is determined by number of protons in the nucleus. Because in nucleus, neutrons are also present, but they are neutral. That's why we consider the number of protons only. That is your That is your atomic number. Now, what is the influence on electronegativity? How your nuclear charge influences electronegativity? So, greater the nuclear charge, the stronger the attraction the nucleus has for electrons. Okay, if nuclear charge is greater, that means your positive part is greater. If positive part is greater, so it will attract more electrons towards itself. So, stronger is the attraction for electrons. As the nuclear charge increases, whenever your nuclear charge increases, moving across a period from left to right on the periodic table, when you move from left to right in your periodic table like carbon, boron, carbon, nitrogen, oxygen, chlorine, when you move from left to right on the periodic table, nuclear charge increases because number of protons increases. Okay, number of protons increases, so your nuclear charge also increases. So electronegativity increases because the nucleus attracts bonding electrons more strongly. As I told you, if nuclear charge increases, your electronegativity also increases because the nucleus, which is positively charged, it attracts the bonding electrons more strongly. Example, if we see fluorine, which has the atomic number 9, it has a higher nuclear charge as compared to oxygen because it has higher number of protons. So that is why fluorine is more electronegative than oxygen. Okay, so first factor is your nuclear charge. Is it clear how it affects electronegativity?
Yes.
You can note it down.